Okay, folks, here we are again. This is section 7-3, chapter 7, of course, and this is video recording number 1. I like to always look back, make sure we're on the same page, we're all oriented as to where we are, what we have done. So 7-1 was confidence intervals for the mean, 7-2 was confidence interval for the mean. The difference was in 7-1 we knew what sigma was, and in 7-2 we did not know what sigma was. Okay, so now we're going to go into 7-3 and 7-4. And what's the difference? The difference is it's the same idea. It's still talking about confidence intervals, but now in 7-3 we're going to talk about proportions, and in 7-4 we're going to talk about standard deviations. Okay, so I commend very strongly to your attention, as always, the textbook is a very good resource for you. These are the important formulas. I'm trying to adjust this here. Give me a second. Technical difficulties. Okay, so this is the important formulas from the textbook from the end of the chapter, and this is the one that we use. We use the Z distribution if we know the sigma when we're calculating the mean, the interval for the mean, and for the situation where we do not know sigma, we use this one. We use the T distribution. If you look at them, you can see they're very, very similar. Now, when we get to the confidence interval for the proportion, it's going to be very, very similar, okay? We're going to have the same idea. P is going to be the true proportion, and it's going to be in this interval. The true P, we're going to say our best estimate is in the interval P hat. This is called P hat. P hat plus or minus this margin of error. Well, the margin of error, again, is the same basic concept. We have a Z distribution that we're going to use to calculate the margin of error. This Z number here, this Z score, is appropriately chosen to give you the appropriate confidence, the appropriate level of confidence. So remember, we pick the level of confidence first, like 95%. That dictates what the Z score is going to be that we're going to choose, and then that's how we get the confidence interval. So it's the level of confidence first. You know, how certain are you? 95%, 90%, whatever, and that dictates what the Z score is going to be. Okay, so let's begin here. We're talking about section 7-3 as confidence intervals, sample size for proportions. Now, the author here talks about how, you know, many times we are really more concerned about proportions than we are concerned about actual numbers. So, for example, you know, something along the order of what proportion of the population is getting infected by this virus. That would be something we would be interested in, not so much about the actual numbers, because it's the proportions or the percentages that help us make some decisions. Like, is it a 1% fatality rate, a 2% fatality rate, less than 1%? It's not the actual numbers. It's oftentimes it's the rates, and the word proportion maybe is not the best word for this, but that's the word we're going to be using, at least in this textbook, okay? So it could be thought of as a proportion as being a percentage, or it could be a fraction, it could be a decimal, and so forth, okay? So here's our definition of all of our terms. These are the symbols that we're going to be using. So let's take a quick look at these symbols that we're going to use. And the way I like to do this is and this is my advice to you, is I read this real quick, but then I jump right to the example, and then I use the example to help me understand the definitions, okay? Examples typically are a lot easier to understand than these abstract definitions. So I'll read this really quick. I'll let you read it as well. Pause the video if you need to, or look in your book. I hope you're looking at your book. Okay, so now let's talk about the example that he uses here. He says, for example, in a study, 200 people were asked if they were satisfied with their jobs or professionals. So 200 people, that's my N. That's my sample size, okay? So I talked to 200 people. I asked them, are you or are you not satisfied? Now remember, these are metaphors, right? These examples are metaphors. It could be you asked them if they were sick. You could ask them if they, had lost their job. I mean, any number of things. And some things perhaps that are more interesting to you. Or it could be, did they get better with this medication? Did this medication make them sick? Did the medication make them better? Any number of examples could come to mind. So don't, as I say, these are just metaphors. Okie dokie. So 162 said they were satisfied. So N is the 200. Okay, that's the sample size. X is 162. So what's this X really mean? X is where you're counting. You are counting the number of successes is what it boils down to. See, X is the number of sample units. Those are the data points, the guys that you talk to, that possess the characteristic of interest. So if you're interested in, are you satisfied with your job? That the number of people that are satisfied with their job, that's your X. If you're interested in, do you test positive for the COVID virus? X is the number of people that test positive. So X is in these examples here, these situations where we're talking about proportions, we're talking about X as being the number of successes. Okay, so now if there's P hat, that's the sample proportion, so that's X over N. So it's 162 over the 200. And then you punch that out on your calculator and it's 0.81. So it'd be 0.81, it'd be the decimal form. Could be 81% would be one way of writing it. Another way of writing it would be just to leave it like this, 162 over 200. Or you might want to reduce that to say it's 81 over 100. Any number of ways that you could write it. Okay, so I hope that's a good example of what we're talking about. Okay, so now this is a situation where we're asking a question, are you or are you not satisfied? Are you or are you not testing positive? So the idea is that a success, we talk about it as being a proportion, that's P. Q is the proportion, or Q hat, I should say. Here's a Q hat. Q hat is see right here, it says Q hat, P hat and Q hat. The Q hat is the proportion of people that are not successful. In other words, it does not have the characteristics. So in this example we just talked about, Q hat would be the proportion of people that were not satisfied with their job. Or it could be Q hat is the number of people that did not test positive for a virus. Okay, so it's always going to be, P is the success, Q is the not success, but since we're taking it as samples here, we have this funny language we use, we call it P hat. And it's going to be complementary, right? In other words, you're either satisfied or you're not satisfied. So if P hat is what the percentage of people that are satisfied, Q hat is 100% take away the P hat. So if 30% of the people are satisfied, 70 are not satisfied. If 73 are satisfied, what would it be? 27 are not satisfied. So it's complementary. That's what he's saying right in here, okay? Okay, so let's take a look here. Got assault victims, got 150 assault victims, 45 took no self-protection action. Find P hat and Q hat, okay? I think that's pretty straightforward. Okay, now, what this should remind you of, okay, I'm going to change gears here. This should remind you of the binomial distribution, right? Because you're either successful or you're not successful. You're either satisfied or you're not satisfied. Doesn't that remind you of the binomial distribution? Okay, so remember back in the binomial distribution chapter, whatever chapter that was, talking about discrete distributions. We had all kinds of interesting things that we learned about the binomial distribution. And then when we went to the normal distribution chapter, we learned that the normal distribution can serve as an approximation of the binomial distribution. So we're going to use that fact. We're going to use the fact that, I felt like I swallowed a spider there. So we're going to use the fact that the binomial distribution can be approximated by the z distribution. We're going to use that fact in order to come up with the technique whereby we attack these kinds of problems. Okay, so in this paragraph, he's saying, hey, it's just exactly like we did before when we were talking about the means. We're going to use a point and an interval estimate for the population proportion. And how do we do it? We take a sample proportion that gives me a point estimate, and then we will find out what the formula is for the margin of error, and that'll give us the interval estimate of the proportion. Okay, so that's kind of what he's talking about right there. Okay, so this paragraph right here really has a lot of information in it. Okay, it's beyond the scope of this class. Maybe if I get time, I'd like to do additional videos on a bunch of this stuff to kind of derive and show why some of this stuff works. But I just for purposes of getting through this class, I can't do that right this minute. Okay, but what he's saying here is that p hat is a random variable. It has its own distribution. It's called the sampling distribution of p hat. So p hat is a random variable. It has a distribution. What does that distribution looks like? Well, if the sample size n is small, if it's not any more than 5% of the entire population size, then you can say that the sampling distribution of p hat is approximately normal. So p hat is a normal distribution. Well, if it's a normal distribution, there's only two things we need to know. We need to know what the mean is. Boom, there it is. The mean is the real, true population proportion. And we need to know what the standard deviation is. The standard deviation is this. It's PQ, well, it's this, okay? So that's what the math tells us. And he doesn't prove it, but you know, if I get a chance, I'll try to do a video about that. Okay. So the point is that this p hat has a certain distribution. The mean of that distribution is the true p that we're really looking for. Okay, so we can go with that. We got what we need. To construct a confidence interval about a proportion, you use the margin of error. What's the margin of error? It's the same as before. It's the appropriately chosen z number. You know, the appropriately chosen meaning the one that goes with the 95% or the 90% confidence interval, whichever one you choose. That is multiplied times this, which is typically referred to as the standard error or something like that. So, I'm sorry, I'm bouncing around here. Right there. That is what we're going to be multiplying by, the standard deviation. Okay? Now, it looks a little different, doesn't it? Here it's PQ over N. Here it's P hat Q. Well, we don't know what P is. If we knew what P is, we wouldn't be going through this, right? So what we do is we substitute the P hat and the Q hat in place of the P and the Q. So the bottom line is, here it is. P is in this interval of, it's between P hat plus the margin of error and P hat subtract the margin of error. This, unfortunately, is a typographical error. It should be N P hat and N Q hat, and Q hat are each greater than or equal to 5. And that comes from our discussion of the binomial theorem. Okay? So there's it looks like a horrible formula, but it's not as bad as you think it is. Okay? And we'll do an example here in just a bit. So that's the end of this video.